Hello, everyone, and welcome to another lecture on organic chemistry. This lecture is related to electrophilic addition mechanism, which only appears in the higher level course. This mechanism explains why alkenes are so reactive and how they react with different molecules. So, in the drawing below, we have got ethene and we've got HBr. Now, this mechanism is called electrophilic because molecules are attracted to the area here of the double bond, which has a lot of electrons. There's 4 electrons. There's a high density of negative charge. So, why would HBr be attracted? Well, in IB, you've already seen that some atoms are more electronegative than others, which means they attract the electrons in a covalent bond more towards them. So in HBr, because of this attraction of Br, you've got a partial negative charge, which is shown as a delta minus on bromine, and a delta plus, a partial positive charge on hydrogen. That means that hydrogen, which is partially positive, is attracted to the electrons of ethene. Now, in organic chemistry and the mechanisms, you will always see the attraction shown by an arrow. The arrow starts in an area or zone of electrons, and it ends on an atom because there's interaction between the negative electrons to the positive hydrogen atom. Now, if you break this bond and bond it with hydrogen, hydrogen has 2 bonds to it, which is, we know that hydrogen only needs 1 covalent bond. Therefore, as this bond is formed, this bond is broken, and bromine ends up taking the 2 electrons from that covalent bond. What do we end up with? We end up with an intermediate phase where we have the hydrogen having bonded. We broke this double bond. We added the hydrogen to 1 carbon. Now, however, the other carbon has lost the electron that it was sharing to the other carbon, so we put a positive charge there. And bromine has a negative charge because it took an extra electron from the hydrogen, so it has a lone pair. So, what is the next arrow we can draw? There must be an attraction between the negative bromine and the positive carbon atom. So, we draw an arrow from the bromine lone pairs to the carbon atom, and you form a bond between these 2 atoms. That's what the arrow is for. It's showing bond breaking or bond formation. So our final product is bromoethane. We added, this is what's called electrophilic addition, we've added hydrogen and bromine across the double bond. Okay, so you see, an addition reaction, you start with 2 molecules, you end up with 1. Now, this same mechanism can work with other molecules. It could work with a halogen, just not HBr, but Br2. You will have in this molecule an instantaneous dipole where 1 bromine will be more positive than the other, and therefore the attack of the electrons can be on the positive bromine. It can also work, of course, on water. So obviously the hydrogen atoms are going to be delta plus, the oxygen delta minus, and the other hydrogen delta plus too. So if you want more details about these 2 reactions, you can look at the previous video on the reactions of alkenes. Hope this helped, and thank you very much for listening.